Hi Year 12s and welcome to our first class on a brand new topic, data analysis. This is the biggest area of study in the general maths course and the contribution to your marks will be 40%. So it's a big topic. We are looking at the very first two sections in the Cambridge textbook. Today we're looking at classifying data and describing categorical data. You'll have done this before. We just want to refresh our memories and be prepared for the kinds of questions that you could get on a Year 12 exam. I've got 5 examples for you in this video. Once you finish this video, I will ask you to quickly skim read the textbook, because reading the textbook is important, and to answer the questions from the first 2 exercises. The first section deals with classifying data. Let me just make a few remarks about why we care about doing this. When you collect data, your goal is to tell the story about what it's saying. And to do that, you might calculate some summary statistics, or you might draw a graph. The kinds of statistics, the kinds of analysis, the kinds of graphs that you can make are dependent on the kinds of data that you collect. If you get the classification wrong, then all of the analysis you do afterwards will be garbage. So that's why this matters. And as we'll see, while most of the time it's straightforward, it's not always black and white, this classification process. But as a starting point, the first question you want to ask when you're deciding what kind of data you have is, first of all, does it involve numbers? But not only that question. Does it make sense to calculate things such as totals, averages, or to perform math operations with those numbers? If the answer to that question is yes, then your data is numerical. If not, then the data is categorical. But please note, very carefully, that categorical data can include numbers. It's just that we can't really make sense of totals, averages, or operations with those numbers. So, let's assume for a moment that we have categorical data. There are further classifications that we can make. So the next question you want to ask is, within those categories, is there a natural ordering? For example, a hierarchy, from first to last, or worst to best. If there is a natural ordering, if the answer is yes, then we would say the data is ordinal. The word ordinal should remind you of the word order. If not, then we would say the data is nominal. And I've listed some examples there for you to look at. You might be surprised by this one, the phone number, because that involves numbers. But there's nothing special about that number. I can't add the numbers up. I can't average the phone numbers to get something meaningful. The phone number is really just a name. And so there is no reason to impose any sort of specific order on those numbers. And that's the reason why most texts and most online forums would actually put the variable phone number under the nominal category. Let's now turn our attention to numerical data. Suppose that you've got numbers and you can do operations with them and find totals and averages. The next question you want to ask is, are there only specific values possible? If the answer is yes, then your data is discrete. If the answer is no, your data is continuous. Now, one thing I want you to note is that just because your data involves decimals, that does not guarantee that your data is continuous. For example, this example here, an amount of money in dollars and cents, that has decimals, but I can't have less than 1 cent. And so that data is still discrete. As a teacher, I report on the Victorian curriculum, and we give a rating in increments of 0.5. And the key word there is increment. Only specific values along a scale are possible. When that happens, your data is discrete. In general, any quantity that involves a measurement, for example, using a stopwatch, using a thermometer, using a bathroom scale, although there may be limitations on the accuracy of those measurements, for example, your bathroom scale might give you your weight to the nearest kilogram or 0.1 kilograms. The data itself, the variable that is being measured, could have further decimal places that are not captured by your instrument. And so we would consider that variable continuous. A ratio involves dividing two quantities. So if those quantities are discrete, once you do the division, any value theoretically is possible. So that's why I've put ratios underneath the continuous classification as well. There are some well-known examples where it's difficult to classify data, and we'll talk about them in a future class. But for now, let's look at some past exam questions. So just had a quick look through some old exams and pulled some of these off. So our first example involves solar energy measured in megajoules and capital city. Now, if you have a background in, say, chemistry or physics, you know that energy is measured in joules, and as soon as you have a measurement, it's a hint that it's a continuous variable. But suppose you didn't know that. Suppose you didn't know that joules was a measurement for energy. The key word here is amount. You're counting something. And so this is a clue that I'm dealing with a numerical variable. Capital cities, on the other hand, well, these are just names. And that immediately tells me it's a categorical variable. That should say ordinal. Apologies. Now, if you look at the options, we're not necessarily required to make the distinction between discrete and continuous for solar energy. But we may need to make the distinction for the name variable, for the capital city variable, whether it's ordinal or nominal. Within the capital cities of Australia, there is no obvious way to order them. So we would say this is a nominal variable. So looking at these options, well, we can clearly rule out A and B because they're different types. We can rule out option C because solar energy is a numerical variable. The best option is D. All right, next one. Here, the variables are number of moths and trap type. If we look at trap type, it should be clear that these are names. So these are categories. So it's a categorical variable. And there's no obvious ordering, so this would be nominal. However, we've got to be careful here. Because although we have a number, the way it is being reported is in categories. There are 3 categories: below 250, between 250 and 500, and above 500. And so this is also a categorical variable. I no longer have the raw counts of moths. And there's an obvious ordering to these categories. You've got the smallest category and the largest category. There's an obvious hierarchy here. So the first variable is ordinal, and the second variable is nominal. I hope you're seeing that the classification of variables is not necessarily straightforward, and that you do need to think about it before you rush to an answer. All right, we're now going to look at two more exam questions for classifying variables, and these are contentious. The online discussions have disagreements with the VCAR assessment report. So here's the first example. So we've got a table, and there are two variables. We have day number, which is just a whole number, and temperature, measured in degrees Celsius. And we have the data for 15 days. Okay, so that table shows us our data. See, and here's the question. Which one is an ordinal variable? If you look at this table, you would think, at first glance, both variables are numerical. Day number looks pretty numerical because there's numbers. And temperature, this one's clearly numerical because it involves a measurement. We would say it's continuous. But an ordinal variable suggests it's categorical. So by process of elimination, you could say, oh well, the temperature one's obviously numerical, so it can't be that one. And so, yeah, we'd write down day number as our answer. But why? Why is day number a category or a name rather than something that we could average or something that we could graph? After all, one of the things that we could do at some point is to draw what's called a time series. We're going to do this later in this course. And you'd have 12.7, 11.8, 10.7, 9, 6. And you could connect the dots. It's very clear that if you drew a picture like this, you would have two numerical variables. So some people disagree with this question. And although the answer is straightforward, it's easy to tell from the question which one it is. The point that I want to make here is that any data that involves a date or an identifier such as a day number or year number, it could be either numerical or categorical, depending on the analysis. So, if I turned this table and drew this graph, fit a trend line and all that, which you might have done in year 11, the assumption would be that day is a numerical variable. But without further information, it doesn't really make sense to add up the day numbers or to average the day numbers with the table alone, unless I'm told something else. So that's why some people would argue that the day number in this particular table, in this context, without any further prompts, is an ordinal variable. Okay? Suddenly, classifying data doesn't seem so easy, does it? Let's look at the next example. All right, so here's our data. It's summary statistics from the Tour de France. And our question is, how many categorical variables are there? Okay, so let's quickly look through the table. Number of starters and number of finishers. Those are clearly numerical. They're counts. Race length, that's a measurement of distance. That's also numerical. Number of stages, that's a count. It's a numerical variable. Average speed, that's a ratio or a measurement again. Numerical. Total time, that's a measurement. That's numerical. Country, yes. that's a categorical variable. Winner, that's a categorical variable. Those are just names. If you've got a name, it's categorical. But what about year? Is year a categorical variable or numerical variable in this context? Well, first question to ask, does it make sense to calculate totals or averages with the year? For this data set, not really. Unless I'm told something otherwise that I want to do for my analysis, there's no reason for me to do that. So, along that line of arguments, if I say it doesn't make sense to do those calculations with the year number, then we would count year as a categorical variable. And hence, the number of categorical variables in this data set would be 3. However, if you did a different kind of analysis, where, for example, you drew a time series of total time versus year, one thing you'll immediately see is that it's going up over time. If I drew a time series, the assumption is that year is a numerical variable. I wasn't told that, so without any further prompting, it seems sensible to suggest that year is a categorical variable. And that's the answer that VCAR was expecting. They considered year, winner, and country the numerical variables in this question. So I make the same comment here. If you're dealing with a date, it could be numerical or categorical, depending on the context and the analysis. So, the reason why I've covered these two examples is because I think a lot of students would look at the year and see, oh, it's a number, so it must be numerical. But just note, historical precedence in VCAR exams has tended to favor the categorical classification. So my advice as your teacher is, unless you have a good reason to believe that the question is steering you towards treating year as a numerical variable, such as a time series, then just keep it as categorical, because that's what they've done in the past. But I will note that other mathematicians and other students online disagree with VCAR, and I actually too would be counted in that group as well. I think without any further prompting, if you ask me if year is a numerical variable, I'd say yes, because you can do a time series with it. So just be aware of that issue in case it comes up on the exam at the end of the year. Now, for something a bit less contested, let's suppose that you've got some categorical data and you're ready to start describing it. So maybe you want to write a report, do some statistics, or draw a graph. There are two ways to display or describe the data. The first one is a frequency table, and the second one is a bar chart. You'll have seen these when you were younger. They're simple enough that I don't need to explain it to you from scratch. We'll just do an example. Please note that frequencies can be described as percentages as well, and this is often preferred because it makes it easier to compare different groups. There is one statistic I want you to be aware of, and that's called the mode. It has the highest frequency in the data set. If your data set has more than one mode, we'd say it's bimodal. And if it has many modes, we'd say it's multimodal. One final comment. If you are asked to do some analysis and you calculate something like the mode, I don't want you to use the term average anymore. This is a statistics unit, so I want you to use the precise terms, which are mean, median, and mode. Now you might be wondering, why haven't I talked about the mean or the median yet? And that's because we're just looking at categorical data today. And when you have categorical data, it doesn't make sense to find totals or to calculate the mean, which is the technical term for what we say average is in everyday usage. If you have categorical data, you shouldn't be finding the mean or the median. Chances are you've either misclassified your data or what you're about to produce isn't going to make sense. So just want to alert you to that. All right, let's finish with an example. This is an old exam question. So what we've got is a sample, we'll define a sample soon, of 96 birds. And they are grouped according to their beak size with the categories small, medium, and large. That would be an ordinal variable because there's a clear hierarchy there. The data is summarized into this frequency table with a percentage. So 25% of the birds have a small beak size, etc. Notice that the total percentage is 100%. That should always happen in a frequency table. Part A. How many have small beaks? So what we want to do is convert the percentage back into an individual count out of 96. So 25% is the same as 25 over 100 times 96. It's a quarter. Quarter of 96 is 24. You might be surprised that 1 mark is given for this calculation, but percentages are not well understood by most students, and you might be surprised later when we do seasonal indices that you might need to further increase your understanding of percentages as well to do those questions. Part B. What we're asked to do in Part B, I'll zoom out so that we can see a bit more of the page, is to convert this frequency table into a segmented bar chart. So the way this works is you have all of your data accounting for 100%. And what we want to do is break it up. In most software, they use different colors. But in the exam, we don't expect you to bring different colors of pencils. So one way we can do this is to shade the bar into different regions with different patterns. And so here they've got the lines, the dots, and no pattern. Notice there's a key. If you are asked to draw a segmented bar chart like this, you should include a key. Do not just assume that we will interpret it for you. So, we know that the small group has 25%, the medium group has 44%, and the large group has 31% of the birds. So the way that we can do this is to start with the small group from 0. So the first region will end, I'll zoom in for you, at 25 on the vertical scale. Sorry. We'll just leave it at this, I think. So 25 is sort of halfway between 20 and 30. We'll do a solid line here. And the pattern is dotted, so I need to put some dots in here. And I'll get rid of the ones in between so that it's consistent. Okay. Now, for the medium group, I want to go from the 25th percentile plus another 44%. That will take me up to 69. Draw another line. And I don't need to shade this one in because there is no pattern provided in the key. The remaining 31% will have the diagonal lines. Now, on the exam, they are very picky about the scale. So make sure that the 25 is halfway between 24 and 26, and the 69 is halfway between the 68 and the 70. Make sure your lines are straight. Make sure the lines on the right align with the scale on the left as well. All right, so that's it from me. What I'm going to ask you to do now is to quickly skim read the first two exercises. That is, skim read the notes and the worked examples, and then complete the questions from the unit outline. I can't remember if you need to do every question, but it should be quite quick, especially the first exercise. Thanks for watching this video. Let me know if it was helpful. Let me know if you want more of these videos, and if you have questions, just send me a message on Teams. See you next time.